Imagine working in a place so cold it makes Antarctica feel like a tropical vacation. We're talking about temperatures plummeting to minus 70 degrees Celsius. That's colder than the surface of Mars on a warm day. For some specialized machine operators, this isn't science fiction. It's their daily reality. But how do you even survive, let alone operate heavy machinery, in such an extreme environment? The answer lies in some of the most incredible feats of engineering you've ever seen. Today, we re-diving deep into the world of sub-zero survival and the mind-blowing habitats designed to keep humans safe and productive in the coldest places on Earth. So, what kind of jobs require people to work in these bone-chilling conditions? Think about large-scale scientific research in places like the South Pole, or specialized industrial processes that require cryogenic temperatures. Operating bulldozers, cranes, and other heavy equipment is essential. But at minus 70 degrees, everything changes. Steel becomes brittle and can shatter like glass. Lubricants and hydraulic fluids turn into solid blocks. Even the rubber on tires can freeze and crack. Standard machines would simply seize up and fail within minutes. This is where the first layer of engineering genius comes into play. Winterizing the machines themselves. These aren't your average construction vehicles. They are metallurgical marvels. Engineers use special steel alloys that remain ductile and strong, even at cryogenic temperatures. All the fluids, from engine oil to hydraulic fluid, are synthetic formulas designed to stay liquid far below zero. The engines are equipped with powerful block heaters and battery warmers that run continuously to ensure they can start. The fuel itself has to be a special Arctic blend to prevent it from gelling. Even the electrical wiring is insulated with materials that won't crack in the extreme cold. It's like building a fleet of rovers for a frozen planet, right here on Earth. But modifying the machines is only half the battle. The real challenge is protecting the human operator. At minus 70 Celsius, exposed skin can get frostbite in less than a minute. Inhaling air that cold can cause serious lung damage. The human body simply isn't built for this. You can't just wear a few extra layers and call it a day. This is where the concept of the operator's habitat becomes critically important. We're talking about the cab of the machine. But calling it just a cab is a massive understatement. It's more like a personalized survival pod. Let's step inside one of these high-tech cocoons. The first thing you'll notice is the insulation. It's not just a bit of foam. We're talking about multiple layers of advanced composite materials, creating a thermal barrier that's second to none. The windows are a feat of engineering in themselves. They're often triple or even quadruple paned, filled with inert gas like argon to prevent heat transfer. A transparent, conductive film is embedded within the glass, which can be electrically heated to prevent any frost or ice from forming, ensuring perfect visibility at all times. You can't clear ice with a scraper when it's this cold. The ice would be harder than the scraper. Now, let's talk about life support. The air the operator breathes can't be pulled directly from the outside. It has to be drawn in, heated to a safe temperature, and then circulated throughout the cab. This is done through a complex heat exchange system that often uses waste heat from the engine. This not only warms the air but also makes the entire system more energy efficient, which is crucial in remote locations, where every drop of fuel counts. The system also maintains a slight positive pressure inside the cab, which helps to prevent cold air from seeping in through any tiny cracks or seals. Comfort isn't a luxury here. It's a critical safety feature. An operator who is cold, uncomfortably, or distracted is an operator who makes mistakes. And in this environment, mistakes can be fatal. So, these cabs are designed for long-duration missions. The seats are ergonomically designed and, of course, heated. The controls are oversized and designed to be used with thick gloves on. Joysticks and buttons replace small, fiddly knobs. The interface is simplified, with bright, clear digital displays that are easy to read in any light condition. But what happens if the machine breaks down? What if the engine dies, and with it, the primary source of heat? This is where backup systems and emergency protocols kick in. Every habitat is equipped with an independent, battery-powered emergency heating system and a survival kit. This kit is extensive. It includes high energy, food rations, water, advanced thermal blankets, chemical heat packs, and a satellite communication device. The operator can survive inside the disabled cab for at least 24 to 48 hours, giving a rescue team enough time to reach them. These aren't just suggestions. They are rigorously tested and certified safety requirements. The psychology of working in such an isolated and extreme environment is also a huge consideration for engineers. These operators often work long, 12-hour shifts, alone in their machine, surrounded by a vast, white, and unforgiving landscape. To combat the psychological strain, the habitats are designed to be as comfortable and normal as possible. They might include a small hot plate to warm up food, a high-quality sound system for music or podcasts, and robust communication links to connect with the main base and loved ones back home. Maintaining that human connection is just as important as maintaining the cab's temperature. The design and testing process for these habitats is incredibly rigorous. Before a new design is ever deployed in the field, it's put through hell in a massive environmental chamber. Engineers can replicate the -70-degree temperatures, high winds, and even the specific atmospheric pressure of high-altitude polar plateaus. They test everything from the durability of the door seals to the performance of the life support systems under a worst-case scenario power failure. Human test subjects, wearing full Arctic gear, will spend hours inside to provide feedback on ergonomics, control layout, and overall comfort. What's really fascinating is how this extreme engineering trickles down into more mainstream applications. The advancements in insulation, battery technology, and synthetic lubricants developed for these sub-zero machines eventually find their way into cars, trucks, and construction equipment used in more temperate but still challenging winter climates. The heated windows on your car, the heated seats, the ability of your engine to start on a frigid morning. Much of that technology was pioneered and perfected in these extreme environments. It's a classic example of how pushing the limits in one area benefits everyone. So, the next time you feel a winter chill, think about the operators working in temperatures that are twice as cold as your freezer. They are able to do their job safely and effectively thanks to an incredible synthesis of mechanical engineering, material science, and human-centric design. These mobile habitats are not just machine cabs. They are masterpieces of survival engineering, tiny islands of warmth and life in a world of extreme cold. They represent humanity's incredible ability to adapt and innovate, allowing us to work and explore the most inhospitable corners of our own planet. It truly is a testament to what we can achieve when faced with the ultimate environmental challenge. It makes you wonder what the next frontier will be, and what incredible technologies will invent to conquer it. Thanks for watching. If you found this journey into the world of extreme engineering as cool as I did, make sure to hit that like button and subscribe for more deep dives into amazing technology. Stay curious.